Hello, welcome back to JD Science Prep. Today we are discussing balancing chemical equations. So if this video helps you, please like and subscribe. So it says, according to the law of conservation of mass, matter cannot be created or destroyed. It can, however, be transformed. That's why when we are balancing chemical equations, we cannot have a different amount of the same element on the product side compared to the reactant side. So just taking a quick look at this example right here, we have one chromium atom and two oxygen atoms on the reactant side. Meanwhile, on the product side, we will have two chromium atoms and three oxygen atoms. Now, this doesn't quite make sense because basically this is saying that there's one extra chromium atom on the product side compared to the reactant side, and also one extra oxygen atom on the product side compared to the reactant side. That is impossible. Atoms can't just pop out of nowhere, so that is why we must balance this equation. Okay, so let's actually go ahead and do that, and then we can look at some steps to actually to follow while we are balancing chemical equations. So we have two chromium atoms on the product side, which means we'll need at least two on the reactant side. And because of this one and three oxygen atoms, we'll need three on the reactant side, so that is impossible. Let's go ahead and erase those. And let's try a 2 right here. So 2 multiplied by the two chromium atoms will be 4. So that means we need 4 chromium atoms on the reactant side. And this 2 multiplied by O3 is 6 oxygen atoms, which means we'll need 6 oxygen atoms on the reactant side. So we are now balanced. Okay, so let's take a look at some steps here. It says when balancing chemical equations, there are some steps. So number 1, it says write the chemical equation with all reactants and the products. Number 2, make note of the number of atoms for each element on the product and reactant side. Step 3, add coefficients to each species so that each element is balanced on either side of the reaction. Step 4 is to just check your work. And finally, step 5, if needed, you can add the states of matter. So just quickly before we start, I just want to label a couple things. So we have our reactant side, which is usually on the left side of our chemical equation. So that's our reactants. On the right side is usually our products. And also, these numbers that come before each species, those are our coefficients. You may sometimes hear them being referred to as the stoichiometric coefficients, but we'll just leave them as coefficients for today. So let's go ahead and take a look at example number 1. We have HGO is decomposing into pure mercury and oxygen gas. So step 2, it says to make note of the number of atoms on each side of the reaction. So we have Hg and we have O, so we have mercury and oxygen on the reactant side, which means we will have the same things on the product side. So right now, looking at our reactants, we are going to have just one mercury atom in mercury oxide. And we'll also have one oxygen atom, and that's it on our reactant side. On our product side, though, again, we have one mercury atom, but here, because of this O2, because oxygen is alone, we actually have 2 oxygen atoms. Okay, so now we can add coefficients to the beginning of each species to balance this equation. So let's try and make everything balanced here. So we know we'll need at least 2 oxygen on the reactant side, since we already have 2 on the product side. So we'll have a 2 in front of mercury oxide. So that applies to mercury as well as our oxygen right there. So we can say we now have 2 mercury and we now have 2 oxygen. And now let's try and get 2 mercury atoms on the product side. So we can go ahead, add a 2. That applies to mercury. And here, this oxygen, because we already have 2 as a subscript, we can just put a 1. Or if you get really good at this, just make it, just leave it blank. That's fine too. So just to make sure, on our product side, we now have 2 mercury atoms and we have 2 oxygen atoms. This is correct. This is balanced. We have 2, 2, 1. Let's move on to example number 2. A little bit of a longer one here. We have aluminum reacting with hydrochloric acid, resulting in aluminum chloride and just hydrogen gas. So we'll write down our reactants. We have aluminum, we have hydrogen, we also have chlorine. We should have the exact same species on our product side as well. Now, one tip I have not talked about yet, I would usually leave oxygen and hydrogen balanced and till the end, just because those are usually the 2 elements that can be found in multiple places throughout the products and reactants, which makes it a little bit more difficult to balance. So just leave those until the very end of your balancing journey. So let's start off. Without balancing, we have 1 aluminum, we have 1 hydrogen, and we have 1 chlorine. We have no subscripts on our reactant side. On our product side, however, we will have 1 aluminum, 2 hydrogen because of this subscript. We'll also have 3 chlorine. Okay, so this is not balanced whatsoever. The only substance that is balanced is aluminum right now, but that is going to change. So the first thing I would do is, I'm just going to try a 1 in front of aluminum chloride, which means I'll put a 1 in front of aluminum. But because we have 3 chlorine, I'm going to try a 3 in front of hydrochloric acid. And you're going to find that this actually doesn't work, because since we have H2 and we have 3 hydrogen on our reactant side, there's no way we can't multiply H2 by anything to get 3 hydrogen. We cannot multiply H2 by anything to get 3 hydrogen. So I'm going to go ahead and we are going to retry. So instead of a 1 in front of aluminum chloride, I'm now going to try a 2, which means we have 2 aluminums on the product side and 2 aluminums on the reactant side. Let's move on to our chlorines. So we have 2 multiplied by Cl3, which gives us 6. So I'm going to try a 6 in front of hydrochloric acid, which means we have 6 hydrogen. And we can multiply H2 by something to get 6 hydrogen. And let's just make sure here. So aluminum on the reactant side, we have 2. Hydrogen, we have 6. And chlorine, we also have 6. And let's see if we match up on our product side. Aluminum, we have 2. Hydrogen, we have 6. And chlorine, we have 2 times 3 is 6. That looks good to me. This is balanced. Last question here. We have KClO3 is decomposing into potassium chloride and oxygen gas. So let's write out our reactants and our products. So we have potassium, we have chlorine, and we also have oxygen. We should have the exact same elements on our product side, which we do. So without balancing, we just have 1 potassium, we have 1 chlorine, and we also have 3 oxygen from that subscript right there. And our product side, we have 1 potassium, 1 chlorine, and 2 oxygen from that subscript right there. So let's see if we can get this all balanced up. So we have 3 oxygen here and we have 2 oxygen here. So I kind of want to find the least common denominator. Okay, so let's go ahead and do that, which should be 6. So I'm going to put a 2 in front of KClO3, and I'm going to put a 3 in front of O2. And to finish off the products, I am going to have 2 in front of KCl. And let's rewrite how many of each element we have here. So on our reactant side, we now have 2 potassium, we have 2 chlorine, and now we have 6 oxygen. Okay, and on our product side, we have 2 potassium, we have 2 chlorine, and we have 6 oxygen. So this is all balanced up. Our coefficients are 2, 2, 3. I hope this video has helped. If it has, please like and subscribe. Thank you very much.